he has been involved in many different things, and what he's doing here lately is he's created a company using the background and technologies and understanding of the business acumen that he's collected over the years to create a company he's going to talk about in detail that provides Internet of Things capabilities to the rural areas. Fascinating what he's done. Where other people have tried and failed, that he is coming up with a business plan and a technology that is going to be, has already proven to be able to do that. And so we're going to learn more about that. This is Peter DeNagy.
Thank you. All right, so we're going to talk about overcoming connectivity challenges to support smart agricultural and rural IoT applications. So let's bring the Internet of Things down to earth, right? Rural IoT are not the same as urban counterparts, right? Smart ag, transportation, oil, gas, renewables, rural healthcare, governmental players have different needs than urban, applications and implementations. And of course, rural providers must provide and implement, capitalize on these opportunities, right? IoT brings immense value to rural America. So, in God I trust, everybody else please bring the data. There are 3.2 million farmers in America, down from, down to 3.5%, 1% in 5 years. Okay? The farms are diminishing. Okay? There are, the amount of acreage is lessening. The average farm size is going up. As a matter of fact, in rural America, they talk about going big or going home on the farms. Okay? By the way, the new census, please note, this is the 2012 U.S. Census data provided to USDA. Now you should ask me, why the heck are you using 2012 data in almost 2019? And the answer is that the Census Bureau runs the ag data every 5 years. The 2017 census is complete, and it takes them 18 months to compile the data. So the 2017 data should be hitting mid-year next year. Okay, so 2012 is still the current U.S. data available. Okay, 40% of the U.S. is considered farmland, 40.8. Okay, how many of you all heard the term fly over America? Right? Fly over America. There's no connectivity in fly over America. Okay, the average age of the farmer is getting up in age, yet the value of ag products has risen 32.8%. Actually, it's now closer to $500 billion. So, when times are good, people eat. When times are bad, what do people do? Eat. You are a smart crowd. Okay. And of course, here are all the farm data. I will make these slides available. Okay. So, here's all the actual data. Okay. The problem is 40.8% of the U.S. landmass is farmland or pasture land. 3 million farmers live there. What's the problem? There's no people there. This is a lovely picture of a farm. The broadband connectivity to the farmhouse is the current reality. There are still a huge percentage of farms and ranches with no connectivity. Okay, so whatever we want to say, IoT needs connectivity to take the data to the cloud. By the way, at the break I told someone, and this is true, okay, there is no such thing as IoT. IoT is basically a candy term. Okay, you have sensor technology, you have communication technology, you have data aggregation technology, which goes to communication technology, which goes to computer infrastructure technology, cloud-based goes to software that makes data actionable. You can get a PhD in all of those elements, but you can't get a PhD in IoT. IoT is basically a term that takes all of those disaggregated industries and packages them to be quickly discussed. Okay? So I'm for it, but please note, there is really no such thing. Okay? So there's no connectivity to the, here. You can do it by satellite. There are some DSL capabilities, but by and large, there's a lot of high-speed problem to farmhouses. Now, federal government is fixing that, helping fix that by providing funding, right? And we'll get into that in a moment. Broadband to rural users provides real value. Precision agriculture, drones, analytics, okay, video monitoring are all use cases. We heard about Bluetooth in in horticultural applications. Tremendous IoT application for for farmers, especially in greenhouses. Okay, I am sure that all the people in Canada will be very interested in that. As they just changed the flag with the leaf on the flag. So okay. Remember the farm? So the FCC has come out with a program called CAF2. And in CAF2, they've just awarded a reverse auction of $2.6 billion to provide broadband connectivity to rural America. Okay? So now, I could provide broadband and Wi-Fi to that farmhouse. That's great. You could do video, you could do high-speed internet, you could do connectivity. But what you can't do is provide the connectivity here. Because you need sensors in the field to do precision agriculture. So they need connectivity in the field. So cellular is great where it's available, okay? But it's not as prevalent as in urban locales. Okay, fixed wireless, there are a lot of new companies called WISPs, wireless internet service providers, coming out using CBRS and localized LTE to do point-to-point fixed wireless, point-to-multipoint. And those are solutions, okay, for a lot of applications. And then, LPWAN provides, coverage for long range, low bandwidth, latency tolerant applications. And we'll go into that in a moment. So, IoT solutions in agriculture also help talk about infrastructure, feed levels, access, assets, soil prep, crop production, livestock, health, silo levels, weather. These are all important because the farmer, the rancher, are the biggest gamblers in the world. Every year they bet their livelihood that their knowledge, somebody's happy about this, they're betting their knowledge that they're going to plant a crop and they're going to make a lot of money. But the problem is they can't predict the weather and they can't predict the production of others and they can't predict the global demand. So if they had tools to better help them, they'd stand a better chance. The good news, there are lots of applications for IoT in agriculture. And copiously, we're going to go through every single one of these applications. Just kidding. Bad news, hardly anybody is connected. Does anybody know why? I'm going to tell you. Cows don't use cell phones. Okay? Have you ever heard of a term called ARPU? Anybody? Average revenue per user. Yeah, you have. It is a metric that the cellular industry utilizes and presents to Wall Street to represent their profits. Okay? In a dense urban area, you get lots of revenue per user, right? Because you all have 4 cell phones at the house. As a matter of fact, the currently in the United States, the percentage the penetration of cell phones to the population stands at 103%, which means every man, woman, child, baby, and a couple of the dogs have cell phones. Okay? Well, you can't grow unless you do other things. And you're not going to add that many more net new subs. Basically, the cell phone companies now are doing a race to the bottom and trading it out. IoT helps out with that. But they don't invest because a sensor in the field is very low monthly cost. And secondly, here's the other problem. This right here, okay, we've all seen these things, the LTE infrastructure. It's $1 million plus. So nobody's going to stand up a cell tower in a field for sensors. I'll give you a story. This is a real story. This is recent, and I'm engaged in this. There's a company, XTO. Anybody here heard of XTO?
Yes.
Okay, ExxonMobil Corporation. So they just signed a $6 billion land lease in the Delaware Basin in New Mexico. And they approached Verizon Wireless, and this is Verizon Wireless. We have 3,500 workers on the Delaware Basin in the 250,000 acres that we just bought. We'd like you to stand up some cell towers because we're going to put in 50 high penetration oil, drilling facilities, and we got 3,400 iPhones, and we think this is great, and we want to, go on Verizon. And you know what Verizon told them? They said, "Are you out of your minds? We will never make money in that deal." Verizon told Exxon, no, because there's not enough money in doing that. So there's got to be a better way. Okay, farmers need to do more with less. Do you know why? There are 7.1 billion people on this planet today. By 2050, there are going to be 9 billion people. We are having less arable land. Water is the #1 resource utilized, in agriculture. And by the way, 70% of all water in the United States is used for agriculture, and we don't make more of it. We just renew it, at best. Okay? And it's under stress, and we have to manage it more. By the way, interesting fact on water, and I have a water slide coming up here, but I'll go shoot the moon right now. What is the #1 crop in the United States that uses the most water?
Grass. Almonds.
Almonds. Almonds. It's almonds, pecans, walnuts. That's right. #1 water user. So, but rural businesses want connectivity to the fields, their facility, the livestock, and the workflow. Okay? So, isn't he cute? Okay? Could be a sheep. We're not going to be sexist here on swine. Okay? So, swine alone is a problem. By the way, there's a huge mistake on this slide. The huge mistake is it says 12% mortality. That's wrong. It's 100% mortality. Okay? Let's put that right out there. It's 12% premature mortality. Okay? By the way, I always keep that there because it's a great joke. Okay? But pigs are really susceptible to disease. They are held in CAFOs, which are pens of 200. So in a small swine operation, you have 4,000 pigs. Okay? And they have the same diseases in profile that we do as well. Okay? So when a pig gets sick, okay, you can get all 200 of them sick. You can wipe them all out. That's a problem. Because a pig is 300 pounds. And it's sold for $1 a pound, which means the pig's $300 when it's sold. By the way, the average pig from birth to dressing, they call it dressing, as opposed to anything else. It's a nicer way to do it. has a 165-day lifespan, which means there's 2 crops a year. Okay? So when you take them from squeal to meal, okay, all right, if they die, it's $300 per. So if they get sick and you lose 200, quick, some of you are math majors, what's 200 times 300? $60,000. Okay? If I can monitor the health of that pig. So let's say I have a Bluetooth tag in the, I'm going to give you a shout out here. I got a Bluetooth tag in the ear of the pig, monitoring the pig's health. Okay? And I know that one of the pigs running a fever. I can pull that pig out and save the other 199. Okay? So now instead of losing $60,000, I'll lose $300. That's a compelling use case. Okay? It's a $9 billion problem. A $9 billion problem is worth solving. Okay? This is the water slide. This is big. And water's a problem everywhere. As a matter of fact, so in California, you've heard California has water problems, right? Okay, so this year, they did something about it. Because the problem is, in Northern California, where the almond trees are, they dig wells. And they go, haha, I don't have to, you can't charge me because I'm digging a well, I'm taking the water out, and I'm draining the water table, but I don't pay for the water. So in 2018, California, first state in the nation, went to taxing water runoff. So now the almond farmers are like, oh my gosh, I'm now getting taxed on all this stuff. How do I go forward and provide precision irrigation so that I can keep my trees healthy and use less water? That's impactful. By the way, word has it that there are 49 other states that may do the exact same thing. Which is also a good way to raise money, right? Farmers want these solutions. And again, we are going to copiously go through all these solutions, right? So, 4 major categories. Agricultural management, livestock management, infrastructure, and of course smart cities. They don't call it smart cities in rural America, they call it smart towns. Okay, and by the way, anything you see up there, you can cross out and say oil and gas because they have the same dynamics. Okay, so IoT requirements to deliver value to a farmer and rancher. Managed Internet of Things, or as IoT AAS company, right? Because everything is as a service. Okay, for ag tech requires the service, the connectivity, a managed services, a target application, solutions, and support. So when we started talking about city applications, right, for Dallas, okay, let me tell you, Goldthwait, Texas wants the same thing. Okay, and I've been to Goldthwait, Texas, and there's nothing there, but I hear there's a football stadium that they're exceptionally proud of. But the net is, they want this too. So why was I in Goldthwait, Texas? So their town's a mile by mile square. They have 400 water meters in Goldthwait, Texas. They want to go and they want to measure the water without having to open up the box in the yard. Okay? Now why would they not want to open up the box in the yard? Well, 1, it's a truck roll, 2, it's a staff person, 3, it's a compliance issue, but 4, it's a health and safety issue. Now you should say to me, Pete, why is that a health and safety issue? So in Goldthwait, Texas, when they open the box, they usually find one of 4 things. A rat, a rattlesnake, a scorpion, or, five. I forgot fire ants. Yeah.
Tarantula.
Tarantula, 6. You got it, right? Do you want to open that box? I don't want to open that box. I had some, by the way, when I looked at the box when I was out there, I had someone else open the box with boots and a crowbar and gloves and everything else like that. It's a problem. If I could put a sensor on the water meter, I don't have to drive by. I can just go and look on my smartphone at any time and read the water meter. By the way, in Goldthwait, Texas, they got a problem because some of the water meters are on ranches. And some of those ranches aren't occupied all the time. So when I heard about the one rancher who was mighty unhappy with his $14,000 water bill because, oh, by the way, he wasn't there and he had a leak, and he came back and there was a puddle in his field, and he dumped $14,000 of water that he had to pay in installments. I understand. They let him do installments. That's a problem. So if you had a smart meter, you can shut that off. Okay? And by the way, going back, so all of this here drives precision agriculture, livestock management, irrigation, plant monitoring, tank monitoring, and other things. All the sensor data is taken to the cloud to do precision agriculture, big data, AI, to provide value and insight. By the way, questions, comments, concerns? Hopefully I'm talking loud enough. If not, I can ramp. Believe it or not, I can go up another level. So, why don't people do this? There's complexity. So farmers and ranchers are some of the smartest people on earth. Okay? They can fix tractors, they can mend fences, they can birth cows. Okay? Not anything which I ever want to do, because I was originally born, you know, in the farms of New York City, moved to the farms of Philadelphia, now I live in the farms of Dallas. Right? So I'm not a farmer or a rancher. So, but I understand about the technology. Right? They don't have the expertise to do this. Right? So when they go do this, solutions are complex. There's insufficient wireless connectivity. The ongoing technical maintenance is hard, and the lack of single source distribution, you know, for this stuff. It's hard for farmers and ranchers. Nobody's actually doing this. By the way, the #1 provider of sensors in rural America is a company called John Deere. John Deere has deployed 14.6 million sensors to their farm equipment. By the way, look this up because this is really super interesting. The John Deere User Association is angry with John Deere because the new software on the new tractors, the tractor calls John Deere for maintenance, and for their COLA, they actually have to accept the technician $150 an hour, even though farmers are used to fixing the tractor themselves. Yes, ma'am.
And the farmers are buying the older tractors because they don't want the new technology.
That's correct. Okay, so the John Deere Users Association actually hired Ukrainian hackers to hack the software. So the John Deere is actually in litigation with the Users Association on the software hack, just to let you know. But John Deere does this to help with the precision agriculture. Yes?
And the Library of Congress just said that it was okay for them to maintain their own tractors, although they're not allowed to hack the software.
Yes.
But they're allowed to maintain their own tractors.
Mm-hmm. That's right.
For the first time.
For the first time.
Yeah.
Yeah, so I mean, this is a big issue, right? But why would John Deere want to do this? Well, because it helps with the precision of the agriculture. And one of the biggest problems in farming, one of the biggest enemies of the farmer is night. So if you have an autonomous tractor, and by the way, autonomy, we you know, so Mike was talking about the autonomous helicopters. That's great. Autonomy is way ahead in agriculture, right? Autonomous tractors, it's already happening. Because if you can plow and reap and sow and plant at millimeter precision, 7 by 24, 365, because the tractor doesn't care if it's dark. It just doesn't. Now the poor rabbit who gets run over by the tractor in the middle of the night is probably pissed off about that, but you know, but it doesn't care. Okay? But the farmer doesn't have the wherewithal to do all the maintenance. Okay? So, especially on IoT precision devices. So, IoT complexity without a value-added reseller. Okay? If you do not have someone doing your IoT, you know, the first thing you have to do is the customer has to identify the needs. Then the customer looks at 7 steps. which are research solutions, validate connectivity, select sensors, run a POC, schedule installation, deploy. By the way, we all miss deploy. Deploy is hard, and then we maintain it, right? So once again, copiously, we're going to go through the entire stack here of what it takes to actually run step by step. Now, you're all engineers. You're all used to these type of charts, right? This is how you deploy any project. Every project you deploy in the discipline of IT looks just like this, okay? But if you're a farmer, okay, and you got your degree from the University of Nebraska, okay, or A&M, you know, because I guess they have an ag school, right? So, you don't do this. This is not your bailiwick. So if you have a VAR is going to come out, or a supplier is going to come out and ascertain, give them a catalog of solutions, you know, they order it, they put it in. That needs to happen for agricultural solutions to develop and drive in rural America, and it's happening. Okay, so as we press on, they also need to select partners that have big data scientists who can source solutions, who vet the products, have professional services, who can deliver analytics and insights, and of course have a cloud hosting infrastructure. Okay? It sounds like every IT project you guys have ever worked on, isn't it? So, we're going to get into connectivity now. Okay? So, and what Illumi talked about is terrific. Okay? It doesn't work as well for the entirety of a big farm. Okay? It works really well on a greenhouse. Okay? And I'm not here to go and talk about one solution over another. But if you look at where connectivity solutions run, right? Bluetooth, Wi-Fi, Zigbee, and I guess we have to modify this because we have to make this range bigger based on your technology. This is a slide from the LoRa Alliance. Just putting it out there. Okay, and then LoRa. So low-powered wide area network, and that's going to talk about low-powered wide area network technologies, have long ranges with small packets that are latency tolerant because you need to connect to the entirety of the field. Okay? So, how many of you are deep in cellular technology and know cellular technology well? You do? You do. He does. She's okay. No. So that's 3.5. Okay, so y'all are familiar with LTE, right? Okay, so there are new LTE protocols that have come out. One is LTE category M1, or category M is typically called. It's 3GPP release 13 of the LTE software stack. Okay, and what it does, it actually divides out the channels on the LTE circuit. It helps with the battery performance, and it provides really much smaller, bandwidth, capability. And it also helps with one of the major enemies of sensor connectivity over LTE. So an LTE network is architected so that the tower calls the device every 15 seconds to say, here I am, here I am, here I am, here I am, right? And that's how LTE is architected. That's why your handoffs work really well when you're driving down, 121 or Dallas North Tollway, or you're driving on High-Five, except for that dead spot that AT&T has. But anyway, okay? But that's how it works. It's really good for a cell phone. It's really bad for a sensor that has a battery. Because if you're saying, here I am, here I am, here I am, the battery goes like this. Okay? That's not good in agriculture. There's a new LTE technology coming out called NB-IoT. So T-Mobile has announced they're going to be the first company in the United States to be deploying that just about at the end of the year. Verizon has announced they're going to be the first company to be deploying that at the end of the year. And AT&T has announced that they're right behind them both, okay? Although they've all backed off. So NB-IoT takes Cat-M1 a step further in a much smaller packet size with a much better battery performance and a much better, sensor, utilization profile. Okay, it is strictly for sensor capabilities. Cat-M1 can do SMS and location. NB-IoT is not designed to do so. You're going to see a lot of that in sensor networks. By the way, T-Mobile's NB-IoT offering is going to be excellent, primarily because they're leveraging the 600 megahertz broadband that 600 megahertz spectrum that they want. It has excellent propagation characteristics, which means it's going to go really far. Okay, so that's going to be really good. By the way, they just announced the pricing. Michael, did you hear the pricing on that? So T-Mobile has announced that you can buy a connectivity package on NB-IoT for $6 a year for the sensor. That's 50 cents a month. Okay, if you buy it in volume, it's $377 a year. It's cheap. Why would they do that? Because everybody's predicting 50 billion sensors connected by the ranges have gone from 2020, which we can all giggle, to 2025, and that's actually what McKinsey said, and I believe that one. Okay? So there are reasons to use that as well. I have LoRa here, but candidly, you can put in weightless. You can put in RPMA, which is the Ingenu, standard, or UMG, which is the Sigfox standard, and they all will perform kind of the same way. Okay, whereas oops, darn it. If you want voice, you need Cat-M1. If you want moving in transit, you need Cat-M1. If you want NB-IoT for low cost and or specific deployments, NB-IoT is great. If you want super good battery and you want long in-range coverage in buildings, out buildings, this is really long range, then LP-WAN is much better to go. Okay, I did not know about 1.6 kilometers on Bluetooth till today, so I learned something. So I'll have to get people to change slides. Okay. So LoRaWAN, long range, low power. By the way, LoRa, when you look at the standard, which was ratified in 2015, stands for long range. Hence the name LoRa. And so somebody said, is this like 802.11.6? I said, no, there are no numbers associated to the standards. It's just LoRa. Okay? So if cell towers cost too much and Wi-Fi doesn't go that far, and where there are no coverage, you can deploy LoRa, which uses 900 megahertz. By the way, why is 900 megahertz a really good spectrum to utilize for connectivity? Anybody? Anybody?
Relatively long range.
Relatively long range. Good propagation. Good building penetration characteristics. But most over, it's unlicensed spectrum, which means it's free.
But there's an inherent problem.
And what's that?
There's lots and lots of users and there's lots of collisions in those 1 kilohertz slots. And every time you have a collision, you have to resend the message. So the more resends, the more collisions, the worse it performs. And since I work for the electric company, I can tell you our 3.6 million meters are constantly sending messages. And that spectrum noise floor is just going like this. And the usability is going like that.
He is exactly correct, which is why we are talking about rural connectivity. Because there are companies doing this in urban, okay, like Comcast and Charter and Cox, are putting together 900 megahertz public networks in urban areas, and they will have collision issues, right? However, I will tell you, very few cows use baby monitors. Okay, and if the rural electric co-op is deploying an electric meter using 900 megahertz to read it, you know what? You'll retune between 902 and 928 to go forward and find the channel without the frequency collision. So in rural America, you know, collision is not the same issue as it is in Frisco, Texas, my friend.
That's true.
But that's an excellent and valid point. So you didn't think I was going to have that answer, did you? All right. And last, LoRa will actually go further, but we like to say that it's a 10-kilometer technology, okay? Which means under good propagation characteristics, okay, you can put up a LoRa gateway and you get a 10-kilometer radius. And if you did the math, it's slightly more than 75,000 acres of coverage. And LoRa gateways are relatively inexpensive. Okay? And that's, by the way, what a LoRa gateway looks like in an IP67 enclosure in a farm. Pretty straightforward stuff. So, if you go forward and you want to connect sensors in the field, okay, you need to look at the topography. So you got solutions here that go into a LoRa gateway or an LP-WAN gateway, and Ed's going to talk about the difference, I'm sure. Which it goes into a network server and application server. Okay, a LoRa gateway will typically only connect up to 20,000 concurrent sensors. And since it's a scheduled delivery mechanism, you can actually run schedules where batteries will last 5 to 10 years. That's really important because if you're burying a sensor in the soil, you're not going to want to dig it up to change the battery. Okay. Now, one of the things also people talk about with LP-WAN is from a security perspective, how does security work? Okay, if you're connecting in the field. Well, there are 3 different levels of security, actually 4. One, LoRa provides a network session key that goes from the sensor to the network server. Okay, so you have to recognize the key or else the packet is rejected. And then secondly, there's an application security key that goes from the solution to the application server. And if you don't recognize the key, then rejects the packet. Third, LoRa sensors use AES 128-bit encryption. Okay, now somebody should ask me, why didn't you use an AES 256-bit encryption? And the answer is, this is a small packet. Okay, a LoRa packet is typically 224 bytes. Okay, so it's really good for the gate is open. The pH is 6.3 in the soil. The water, the moisture content in the soil is 18%. Okay, the water meter is at this value, right? Really good at that. Okay, really good to see if the outbuilding has a fire, to see smoke or CO, connector. Really good to tell me that the temperature of the pig is 102.6, it's running a fever pulse. Really bad at sending an SMS. Can't do voice. Okay, so think of a 300-watt modem. That's what you're connecting, 300-watt modems. But for most applications, that's really good because the sensors are cheap, the batteries last forever, and you're only requesting 1 or 2 points of information. The LoRa gateway, as I think I said earlier, will only handle 20,000 sensors concurrently. So you put a lot of sensors out there doing different single point purpose things. You're shaking your head.
I'm not sure I see the sense in having encryption on most of those things that would essentially be sensors with low value, low information value. There are some that have higher information value, but most of those that you're talking about in a farming environment would have low information value.
You're right. That being said, if you don't design a standard with the security in there, you can't take it for other applications. So one of the so candidly, one of the use cases for LoRa is asset tracking. In asset tracking, so let's say you had a 1 million square foot warehouse, and instead of using RFID readers, you put LoRa tags on all the high value assets. You could have one gateway handle the entire warehouse and then pull them all up, and you'd want an encryption schema built in there.
Okay, so it's essentially for standardization across all
It's in the standard.
all sensors.
That's right. So let's say I have a smart city application. One of the really big smart city applications for LoRa is street lights, school signs, monitoring trash bins. Is it full? Is it empty? Manhole covers, is it displaced? There are security elements to that. Because if I could, I mean, I don't know, did Dallas have 164 tornado sensors go off at 2 o'clock in the morning for an hour one night last year?
Sirens.
What?
Sirens.
Sirens, sorry. Did it happen? Sure. Do you want security on that? Yeah. But you're right. By the way, there is a fourth element to security that goes right to what you wanted to say. Because you have to understand the bit stream coming from the specific sensor. And since it's a binary bit stream, you have to know the sensor and the lat long to know what the data you're getting. And then you have to really want to know if the pH of the water is 6.2 and you care, right? So in agricultural, there's not a lot of hacking, but from a smart city perspective, yeah. Let's put this in oil and gas because this is great oil and gas too. Would you want to encrypt to know if the pump is working or not, or if the oil container is at 82% full? You probably want to encrypt that, right? Maybe. So it's there. Okay. I gave you an actual Visio because I know you're engineers, so I want to make sure that you all saw Visio as well with that. And again, just one more time, how it works. You take an end device, you connect, you send the signal to the gateway. The gateway connects to either LTE or broadband to bring the LoRa back to the cloud. And then from the cloud infrastructure, you send it to the applications. Okay? So now I have this farm. And before, I didn't cover out here. Now I cover the whole farm. And I can put sensors everywhere. One of the biggest applications in irrigation is monitoring the irrigation pivots. One of the biggest applications on a farm is tank monitoring. I was in North Dakota, I was in Fargo, North Dakota, speaking at an event a month ago. Farmer told me a sad story. Farmer went on vacation. The farmer in town went on vacation, and he had filled all his water troughs. He had 36 water troughs on his 10,000 acre farm. Okay? They had a heat wave. He was gone for 4 days. When he came back, 4 of the water troughs were empty, and 240 of his cows were dead. Because cows are stupid. Okay? And they wouldn't walk to the other ones. They didn't know better. They just circled the 4. Okay, looking for water. Okay, and they died of dehydration. Now, we talked about a pig being $300. Well, a cow's $2,000. So that farmer lost $242,000 cows. Pretty darn close to $500,000. Okay, if I would have had a monitor on the tank, okay, he would have had that. He'd call the next door neighbor because he's on vacation and say, could you dig your truck and fill up these tanks? Just, food for thought. So the value proposition, high-speed solutions are very required for fiber and Wi-Fi. Connected fields are great for analysis, okay? And then delivering solutions for real ROI and TCO are what your farmers need, okay? And rural America wants this right now. All right, so I didn't do much of a company pitch, but I'm going to do a little company pitch now. So I was the keynote speaker at the NTCA conference a year and a half ago, and I was talking to 500 engineers about how they're going to make money in 2020. And of course I was talking about SDN, SD-WAN, NFV, GPON, G.fast, all sorts of communications protocols. And then I got to LP-WAN, and there are 500 people in the audience. I said, how many of y'all are looking at LP-WAN? So 5 goes, hey, let's go up. So I was a politics major in college, but I know enough math to know that 5 hands out of 500 is 1%. And that's not good. I said, so of you all, how many of you are actually doing a trial? So 3 of the hands go down, 2 hands are still up. 2 people out of 500 are actually doing a trial on LP-WAN. So then I asked the fateful question, do you both work for the same company? And they go, uh-huh. And I said, well, why aren't these people doing this? Because this makes all the sense in the world, because you need sensor connectivity to do all these things. Because precision agriculture in livestock and growing is how we're going to feed 9 billion people in 2050. Because there are going to be fewer people with less land and fewer resources to do it. So why aren't they doing it? Well, the MSPs out in the country, they don't have data scientists. They don't have analytics engineers. They can't vet solutions. They don't have the technology, they're not trying it. And oh, by the way, they've been burned from a CapEx perspective. So I said, you need an MSP to do that. And I founded my company, which is IoT America. I started a year and a half ago. We launched in June. We have had unbelievable immediate success. Our value proposition is simple. We provide our go-to-market providers the services for rural communities. We provide a vetted catalog of solutions. We manage carrier and private networks, and we provide the analytics, the cloud services, and the back end for ranching, farming, oil and gas, and smart towns. So that's what we did to start the company. We're doing good. This is the press release. I don't know if you've ever heard of this newspaper, the Wall Street Journal. This is a press release to sign up the deal we just signed with US Cellular. So we are actually providing US Cellular and their 5 million customers managed IoT for rural America. So it's a pretty good sized deal. Okay. We just won Rural IoT Product of the Year in Compass Intelligence, okay, for all of rural America. We were just named CCA. CCA is the Competitive Carriers Association. It's basically the association of all the wireless carriers in America except AT&T and Verizon. I mean, literally, they just let Sprint and T-Mobile in. So there are 110 wireless carriers in America, and it's everybody but Verizon and AT&T. And so we were just named Startup of the Year this week. So, and our categories are infrastructure, livestock, agriculture management, small towns. We do not put oil and gas up here because it's usually a different conversation. We do oil and gas too. That's all we do. Because we're not going to the cities because of the exact problem that you said. Because that is a problem.
Well, if you were out in the oil patch in Midland, Odessa, and you tried to put up a 902 to 928 unlicensed spread spectrum system, you would run into problems.
Yeah.
So there are non-urban areas that have that problem too.
That's true. But you can tune. There are other methodologies for that. But yes, you're right, because there's contention, because people have been using 900 for a long time. Okay? So I wanted to show you some of the really cool applications. I love the name MooCall. MooCall. It's a real company, Google it. They're based in Ireland. And by the way, they have one of the best solutions. They have a heat solution for cows, and I'm not talking about temperature. So they make cheese in Wisconsin. I'm sure you all heard that. They have a lot of dairy in Wisconsin. So they breed cows, and you have to breed cows frequently so they keep giving milk. So cows typically give birth in February, okay? I don't know if you've ever been to Wisconsin in February, but it's not pretty, okay? And the poor farmer's got to go out there and wait with the cow to give birth. Not because the cow can't give birth on their own, okay? And not because there's a risk that the cow could step on the calf, which by the way could happen, but the risk is that the calf's going to freeze to death. So the farmer's got to go out there. Unless they put a moo cow sensor on the back of their tail, and then when it starts going, the blessed events start happening, they get a notification saying, come to the barn. Let me tell you something. The rancher's happier. The likelihood of successful births because they're immediately there when the start happens, okay, and the fact that, you know, everybody is much safer. You know, again, in the pig example, we talked about 12% premature mortality. How many people here work for Lockheed Martin? Okay, half the room. 62.7% of the room works for Lockheed Martin. Okay? You guys make what, the F-35 here? Is that right? Okay, do you guys have a 12% shrinkage problem on the F-35?
That's classified.
My gut level is they're spendy, right? You don't have a 12% shrinkage problem on the F-35. If you did, you'd probably go bankrupt. Well, they have that in pigs and cows. So if you can actually take that number down, that's a big thing. Okay, cow lard, this is a great thing that you put a collar on the cow, right? You know, and these are all different types of cow. You know, and we're talking about health, temperature, birthing, feeding, nutrition, so on, so on, so on. Asset tracking, right? You know, one of the biggest problems is lone worker. You know, farmers are out on the field, right? There's no cell coverage. Oh, crap. I fell out the tractor, because these tractors are big. I got a picture of me, by the way, I have a great picture. I was at a farm show. I'm next to this enormous tractor that was made by Jaguar. So, I mean, this, you know, I didn't know that they made tractors, right? So I'm sitting next to this Jag, right? You know, and it's taller than the room, right? And you fall out of the tractor, you could break a hip. What do you do if you're in the field? You break a hip. You know, with LoRa, since there's geopositioning available, you can do lone worker push for help, and it will track you instantaneously. Now, the triangulation on LoRa stinks compared to GPS. It's terrible. It's within 30 meters. You know what? I can find a cow in 30 meters. I can find a person in 30 meters. That's real good. Yes, you have a question? Or was that just a twitch? Okay. Question?
What are you doing to track wildlife threats like?
Great question. So,
Lions.
okay. So like if you went to community, so if you go to like Connectera, I'm sorry, move back, button failure, right here, they do ear tags on cows and livestock. You can tag any type of livestock within reason. Like, you know, you can't tag a chicken, okay? But you can monitor the hen house or the facility, right? But like, let's say, so we have one customer in Texas that has a preserve that has exotic animals for hunting, and they want to tag them. If you wanted to go, so somebody was telling me today about in Alaska, they want to tag the bears. They don't want to kill the bears, they want to tag the bears. So when the bears come close, you can go forward and do that, no problem. Any type of animal. Alpaca, llama, goat, you know, exotics.
I'm asking about a farm threat though.
What?
Like a coyote or an outlaw. The livestock.
Oh, it's a great question, right? So one of the things you can do is herd management. So typically a lot of people, what they do is they geo-fence the ranch, because you're not really wanting to look where every cow is, but you want to know where the cows move as a herd. So typically speaking, you can actually see the herd management, and then you can actually make some predictive, response based on that. Because if a coyote goes, you'll see all of a sudden some unique characteristics, right? One of the things also which is really nice with herd management, so when cows get sick, typically what ends up happening, the cows all huddle together to go and help the sick cow through. But when the cow gets really sick, then they all disperse because they're waiting for that cow to die. So by the herd management characteristics and tracking a cow, yes, a boy from Philadelphia knows way too much about this stuff. You actually can go and do much better herd analytics for that. But you could actually look at group analytics to do that. Make sense? Yeah. All right. So a lot of asset tracking. So there's a lot of assets that you can track. One of the things, I love the GlobalSat solution. So the GlobalSat solution is great because you have a sensor which is LoRa and GPS. So the problem with GPS sensors, they use batteries, a lot of battery. So with this, what happens is it does last position. So when the sensor moves, it automatically triggers the GPS, gets the final coordinate, sends the final coordinate back. So you don't use the battery like you would in a traditional GPS application, and you still have the LoRa efficiency in that. Okay, really good for high value stuff. Okay, but they actually make small tags for regular that actually compete very favorably in an overall TCO or ROI model to RFID. So if you did like passive or active RFID, because you don't need readers. You have one gateway in a warehouse. You can read, tens of thousands of packages. Tank monitoring, we talked about tank monitoring. So one of the biggest things is in rural America is propane and diesel. Every farm has a diesel tank. Every farm has a propane tank. Propane dealer goes on schedule every week, goes, checks the tanks. If you could read the tank and see if it's empty or full, you can reduce the truck rolls, provide better customer services, and oh, by the way, you eliminate that call saying, oh my God, I'm out of propane and my house is 42 degrees. So that's what's happening in rural America. I could talk for hours and hours and hours on the use cases. By the way, marijuana is a big use case. Okay. Really, really big. Vineyards, big use cases. Almond trees, big use cases. Cattle, pigs, big use cases. Question? Question? You.
How do you judge?
Easy. Go ahead, I'm sorry.
How do you judge them? Like, you judge them by the price. How do you judge?
How do you charge?
Like, listen, how do they pay you? How do they pay you?
That's great. You want to know the business model. So our company has a very simple business model. Okay, so we work with rural wireless carriers, rural broadband providers, rural electrical co-ops, because they're not like Encore, all right? Rural towns for water meters, WISPs, which are wireless internet service providers, and MSO, cable companies. Okay, so we work with them, and in a no CapEx fashion, we actually provide them a gateway. We send them the gateway. They install it, we charge the customer, and our minimum price is $200 a month. And on that $200 a month, there's a rev share, which I'm not going to go into, between us and the wireless carrier. Okay, and for that, they can connect up to 200 sensors. Okay, and we actually we'll actually monitor the sensors, do heartbeat. Okay, then of course they have to buy a sensor and they have to buy an application. We take the data from the gateway and put it into our cloud instance. By the way, we use Cassandra for all you data wonks in here, okay, as our unstructured data source. And then we run an API out, okay, a RESTful API out from our data source to their application. After 90 days, we purge the data, because it's not our data. Okay? We instantiate the lat long on every sensor from a metadata perspective, as well as what type of sensor it is, and so we know which application to sell and send to which solution. And at that point, you know, we go from there. Now, every sensor after $200 is $1 a sensor per month. If you have a cow solution or a pig solution, which is, you know, 2,000 sensors, it's less. If you had electric meters or water meters, it's less, and it's usually bundled into the solution. Because the gateways are pretty inexpensive. You can buy and install a LoRa gateway yourself for under $3,000. But you got to manage it, run it, and do everything. And we do it in a no CapEx basis, which means that all of our partners, they don't have to buy the equipment. We just send them. They like that a lot, because all they're doing is billing and making margin from day one. And the industry seems to like it. And like I said, we signed up US Cellular. We have a lot of other contracts coming and have come, but I'll give you some US Cellular statistics. So US Cellular is not a Fortune 500 company. They are the nation's 5th, soon to be the nation's 4th largest cell phone company. Okay, when T-Mobile and Sprint merge, if that happens, they become number 4. They have 5 million customers. They're not a Fortune 500 company because they're Fortune 502. So they're a $5 billion company. So they've looked at the model, they say, oh, we can't do this cheaper than you're doing it, let's do it. And I will tell you that we're in conversation with almost every small rural wireless carrier in America, because they all love the model. And I'm not going to tell you about the NDA I signed with Sprint yesterday. Yes?
Okay, so you had a chart, it was a coverage chart, showed, hey, this technology is best for
I did.
GPS, is best for this. Yeah, that page.
Is it, no, it's up here, wasn't it?
Did serve you midway through. But it seemed to me on that chart.
I'll show you the Wall Street Journal article all the time. Just kidding. I think it was up here.
It seemed to me on that chart it was saying that the LoRa standard, the LoRa technology wasn't as good. Yeah, that's the one. And that wasn't as good at mobility.
Yes, terrible movement.
So
LoRa is a fixed sensor technology.
So
if you have something in motion that's over 40 miles an hour, if you had a cow, it does motion on a cow.
So what about a tractor?
Yeah, fine.
Tractor's fine.
Tractor's fine. Tractor doesn't go fast.
Okay.
It's a 40 mile an hour limit.
40 miles. Okay.
I mean, it's not an in-transit technology. If you wanted to do in-transit, and by the way, NB-IoT is not in-transit either. You really want to go to Cat-M1 if you have motion in play.
So you couldn't put it on a truck.
I'm sorry?
You couldn't use it in a truck.
In a truck?
You couldn't.
So you're not going to do like fleet management or telematics in it. No, absolutely not. If you had a gateway in a truck, you could do it to manage the assets in the truck. But you're not going to go forward and use it for fleet management.
So it's relative speed, not actual speed.
That's correct. Relative speed, yes.
It's intended, 902 to 928 is intended for fixed applications.
That's right.
And by FCC rule, they really don't want you to use it for mobile applications. Something on a small area, like in a farm and a tractor, they'll probably let you get away with it. but they really don't want you to use it on mobile applications.
So I actually had the conversation directly with Mignon Clyburn when she was one of the 5 FCC commissioners, and she was happy as heck with that. Okay, the FCC, we've already talked to the FCC and the USDA about it, so they're fine with tractors, and yes, I have a selfie with her too. So, but anyway, other questions? Did I run out of time?
You're out of time, but we have 25 minutes or whatever until the next session. So if you'd like to come up and ask any questions afterwards, you're welcome to. So let's give him a hand.